Now we'll see subnetting idea in classful addressing. In classful addressing also same way we can do subnetting, but the only thing is we will see there is a difference. So we are going to borrow some bits generally in classless addressing also, though I did not mention that we borrowed some bits from host part, right? And based on that bits we divided multiple subnets, correct? In the same way here also we are going to borrow some bits from host part, but we can borrow from anywhere in the host part. But in classless addressing we borrowed only from most significant bits. Okay, now we'll see subnetting in classful addressing. For that, let me take a class C network. Whenever it is a class C network, then it will have 3 octets for network ID, 1 octet for host ID. Already I explained you. Second thing, so the pattern in the first octet will be fixed. That means 110 followed by something. Because of that, so definitely your network starts with 192 or more than that. So 110 is fixed, then 192 plus something you get. So 192 plus networks are nothing but class C networks up to dash maximum. This will be what? 11111, right? So if it is 110 followed by all 5 ones, that is going to be maximum value in this octet. So that would be, let's add 31. That's why, because this 5 ones is nothing but 31. So 192 is compulsory plus this 31 if I add, so maximum you are going to get 223. That's why in class C network first octet will be definitely 223. Otherwise sorry, it is between 192 to 223. When it will be 192? If all these 5 bits are zeros, you are going to get 192. That's why by seeing this a value between 192 to 223, I can say whether it is class C or not. So remember, from now onwards every class C network will fall under, otherwise fall between 192 to 223, especially first octet. Now second octet, third octet, fourth octet can be anything. Okay, almost. Now let's take such one class C network. Okay, let's take 192 dot something, let's take 28 dot something 32.0. This is class C network, one of the class C network. So what is network part? These three octets are going to talk about network part. This is host part. Okay, so host part all bits 0 means what? It's a network address, right? Network ID. So now what I want to tell you is how many addresses we have in this class C network. Since this is host part, there are 8 bits. That's why I can say 256 addresses we can have. Out of them, so 2 are however going to be wasted. One is for network address, second one for broadcast address. Then there will be 254 hosts. That means you can connect 254 devices. Okay, now so I am going to divide your network. Already you have class C network. Okay, that means you have addresses such a way that you can have one class C network. Now I would like to divide that into 4 parts, 60 each. Okay, approximately I have 60 hosts in each network. I would like to divide like that. If I do that, then question number 1, this is class C network for total 256 addresses, correct? Then if I do subnetting, what is each subnetwork? What is the ID of each subnetwork? We have to find out, correct? Let's do that. So for that, so we cannot disturb 192, we cannot disturb 28, like because authority gave us pattern 192 fixed, 28 is fixed, 32 is fixed. Only that last host part we can change. So now in the host part we can have anything, but if you want to systematically group them into 4 parts, then 2 bits are required. Okay, so using 2 bits I am going to separate them into 4 networks. So one is 00, I can borrow from anywhere. I can take 00011011. This is one model. Let me focus on this one. So in classless addressing, same thing we did. Okay, so 00, and because at that time we were focusing on uneven networks, so we did in a different way, but general idea is this one. By this time you should get experience. So since you have 4 subnets of equal, that's why I am taking 2 bits. So 00011011, and you check the remaining bits. How many other bits you have? 6 bits for host part. Okay, so sir, this is also host part, right? No, now it is going to be network part, which is created by you. Already this is network part, of course, but we are borrowing 2 bits from host part to separate this network into 4 parts. According to the world, they are thinking that you have a one network. That's why they gave you this pattern. Now you are again further dividing into 4 parts, then you need 2 more bits, but no one will give you. You have to take from your host part. That's why 2 bits are dedicated for that. Then if you see, the remaining 6 bits are going to decide your host. So how many patterns we can have with 6 bits? By fixing 0 0, if I fix 0 0, then 64 patterns we can have. If I fix 0 1, 64 patterns, 1 0, 64 patterns, 1 more 64 patterns. So each 64 patterns I can give to one network. It's up to you. Okay, let's say network 1, subnet 1, SN1, SN2, SN3, SN4. Let's take subnet 1. So for subnet 1, what we do is we give 0 0 pattern. It's up to us. Okay. Then the remaining bits you can vary. That is going to be host part. Okay. So now what will be the, if you want to know the network address of this one, simple. In the host part you write blindly all zeros. You get the network ID. So 6 zeros. Then you are going to have 192.28.32 dot. Okay, now see all zeros, right? 0. This is going to be network ID of subnet 1. Okay, so here there is no prefix part anything, it's fixed. Okay, so I can say that network part, if you want to know, already you have 4 plus 4, 8 plus 4, 12 bits for network plus 2 more bits. I can say 14 bits for network. Okay, second thing, now SN2. For SN2 what we do is, we start, because you know already 0 0 is given for network 0, network 1, right? For this one we give another pattern 0 1. If I give 0 1, then you are going to create a new network. Okay, that is 192.28.32 dot. If I write 0 1, what is going to happen? So remaining bit should be zeros, then only it will become network ID. So 3 plus 3 6. So what will be the value in the decimal? It will be, see, this position is nothing but 64, correct? So it would become 64, 32.64. This is the network ID for subnet 2. Now similarly, third subnet will be, definitely easily we can guess it. So 0 0 will become 1 0. 0 0 0 1 1 0. If it is 1 0, then the weightage will be 128. All this is definitely 0, 128. You get 192.28.32.128. Remember one thing, host part should be always 0 to get the network ID. The last subnet is 192.28.32.128 will become now this time 11. That means 192. So these are all various subnets. Okay. Now I am going to teach you what is subnet mask also. Before that, can we do, subnetting in a different way? Can we borrow other bits other than, the first 2 bits from the host part? Yes, we can do it. Remember it. Definitely in classful addressing, we have to borrow from only this host part. Okay, and especially that in that host part, you can take from anywhere. Remember it. Okay, you can take from anywhere, but in classless addressing you can't do that. Always we have to borrow like this only. Example, if you want to borrow 2 bits, definitely it should be from most significant bits. That is the only difference. Now if the problem is classless addressing, then also same way we can do. Okay, but now I am going to tell you one more method where we are borrowing from middle, but that is only possible in classful addressing but not in classless addressing. We will see that. Okay, now we'll see how to borrow from middle. Okay, for that again I am taking class C address. So this is a class C network. 192 is fixed, we can't disturb. 64 is fixed, network part. 32 is network part fixed. Only host part is last octet, correct? Now in that, so we have variable part. Right? That means anything you can fix. 1 2 3 4 5 6 7 8. Let's take middle things. Okay, these two. Let me give weightages. This is 128. This is 64. This is 32. This is 16. This is 8 4 2 1. Isn't it? Now let me fix these two. So in this one, same problem. I am going to have 4 networks. 60 here, 60 here, 60 here, 60 here. For that, what you do is you take here 0 0 and 0 1 and 1 0 1 1, and again it is not compulsory to be contiguous. You can take 1 bit borrow from here and 1 bit borrow from here also, not a problem. Let me take these two now, 0 0 0 1 1 0 1 1. If I take 0 0 1 subnet, second subnet, third, fourth, let me target first of all 0 0. So if it is 0 0, then host part is this part, right? These two bits, these two bits. Question number 1. What is the subnet ID for this one? Subnet 1. So subnet 1 is going to be, so 192.64. Okay, 32 dot. Now see this part. So this is host part. 2 here, 4 bits here. If all are zeros, because to have subnet ID, host part should be zeros. Then it would become 0 automatically. So this is subnet 1. Next, subnet 2. So subnet 2. In the subnet 2, so we are going to have here 0 1. If it is 0 1, then the weightages are 32 and 16. So it will be 48. So you get 192.64.48, sorry, 32 dot 40, sorry, only one, right? I'm sorry, 16. This is second subnet. Third subnet, for that we keep 10. If you keep 10, then you are going to have subnet 3, that would be 192.64.32 dot this part now. So 10. What is the weightage of 10? This is 32, right? So it would be 32. The last one, subnet 4, 192.64.32 common. Then this 10 is going to be 11. Host part again zeros only. So it would become 32 plus 16, 48. In that way, I can say subnet 1, subnet 2, subnet 3, subnet 4. And ask yourself, what would be the, systems? If you want to know all the possible systems in this network, how you find out? Simple. So I am not going to discuss that. You can do it. Simple. These 6 parts are going to be host part. See, 0 0 0 0 0. Then 0 0 followed by 0 0 0 1. 0 0 1 0 0 0 1 1. In that way, vary all these bits and all these bits and observe the patterns. They are all going to be part of this subnet 1. And unnecessarily, you can easily observe that they are not contiguous. Correct? See, first of all, if it is 0 0, then with 0 0 you get 0 0 0 0 0 0 0 1, so on up to 15 you get. Okay, so easily we can see that the network addresses in this subnet 1 is 192.64.32.02. I'm talking about in the first subnet. This is 0. Okay, now you get 0 to 15. After that, let's talk about 1 1. If this is 1 1, what are the addresses you are going to have in subnet 4? If it is 1 1, then all zeros is 1, of course network ID. After that, if I keep here 0 0 0 1, that is the first ID, I can say, right? So what it will be? It will be 48 plus 1, 49. Next 10, 50, 51, 52, 53. But after some time we have to vary this also. Then you get another sequences. Finally, so it's up to you. You just find out, treat like a homework. What you do is, question is, this is your subnet, right? 1 1 followed by this 2 variable, this 4 are variable, right? Now how many different ways you can vary, right? Keep all possible binary patterns here, 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 here. Then you get all addresses belongs to that subnet and observe, are they sequential or not? Okay, so easily we can find out. Now this is about subnetting and especially borrowing from in between, otherwise arbitrarily from the host. Now one more thing, we know what is mask, right? So far we have seen mask for a network, correct? What is mask for subnet? That means when you created lot of subnetworks, then they also will have masks. Generally we call them subnet mask. So let's focus on subnet mask. How to create subnet mask? It is very easy. Whenever you have a subnet, then identify the ID network part. Okay, so when you borrowed some bits, they also will be part of your subnet part. Okay, that means network part. Then all that bits are going to be ones in your subnet mask. Already you know what is mask. Recall, mask is nothing but in the network part you have ones, host part zeros, correct? In subnetwork also, in the network part you write ones, in the host part you write zeros. That will become subnet mask for that corresponding network. Example here we see directly. So what is the network address of this one? 192.64.32.0, right? So tell me which bits are going to be network part? This one, all these bits network, and 2 bits here, right? Network. network. I can say network, 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 these 2 bits. Okay. Now all remaining bits whatever you have, make them zeros. You will get subnet mask for network. Okay. So here that would be if I write all ones. So in this network part if I write all ones, that will become 255, right? Now this is network part, all ones, 255. So where is other part of network? This one. This entire thing is network. So all ones 255. We are forming subnet mask. Now still we have network part here. 2 ones. Here one because it's network part. Then it would become 32 plus 16 48 and all host part should be 0. That's why you get 48. So this is going to be subnet mask for one of the subnet 1, right? So what about subnet 2? In subnet 2 also if you see 192.64.32.16, right? So same thing, that same network I can say, right? 190, this is same, this is same, this is same. Only the difference is here again you borrowed these 2 bits only. What I want to say is all subnets are having same network part, correct? So for all of them network part is same, right? This one, this one, this one, everything same. And network bits also same, these 2 bits also. That's why, so I can say that for every network here you get same subnet mask. That is one important observation. What is the realization? When a network is divided into subnetworks, every subnet will have same subnet mask, correct? If you equally divide, here especially we equally divided. Sometimes if you don't equally divide, for some networks if you use more bits, for some networks we use less bits. Did you remember when I taught you classless addressing? At that time we divided our subnetworks into unequal parts. At that time for some networks we took less number of bits. That means borrowing, we took only less number of bits for borrowing. For some networks we took lot of bits for borrowing, right? Then definitely you get different subnet masks. But here it's a special case. So here all the networks are having 2 bits borrowing, correct? That's why you got same subnet mask. Okay.